Hi, this is Mrs. Huntley. This is Module 4, Lesson 9, an application of linear equations. You should be on page 66 of your student notebook. Your essential question for this lesson is how do I use what I know about linear equations to solve real-world problems? The first discussion question is related back to Module 1 on exponential growth, and it's a question about Facebook and sharing a photo and how if everybody shares it, with 7 people, how fast it grows. We did not do this problem. We skipped this problem, which was an option in lesson 1, or module 1, I should say. So we're also going to skip it here. And we're going to go all the way to page 68, and we're going to do the alternate problems. With this particular lesson, we could either do that first multi-step equation problem with the one exercise, or we could do exercises 3 through 11. So we're going to choose to do the 3 through 11. So let's start with Marvin. Marvin paid an entrance fee of $5. Oopsie, we didn't lock everything in place here. Marvin paid an entrance fee of $5 plus an additional $1.25 per game at a local arcade. Altogether, he spent $26.25. Write and solve an equation to determine how many games Marvin played. So this lesson, how it's different from other lessons, is we're combining what we learned in lesson 1 and lesson 2 and the last few lessons that we've been working on. So not only are we going to be translating word story problems into number sentences, but once we have those number sentences, we're going to find a solution and actually answer the question that's being asked. So Marvin paid an entrance fee of $5 plus an additional $1.25 per game. What are we trying to figure out? How many games at a local arcade? Altogether, that's our key word for equals. So let's define our variable. X is the number of games Marvin played. So we have 5 plus 1.25x, because we have to multiply that $1.25 for each game that he plays, and all together equals $26.25. So now we go through the steps of solving the equation. We do not have parentheses, so there's nothing that we're going to be distributing. We do not have any like terms on either side of the equal sign, so there's nothing to combine. All of our variable terms are already on the left. So the first thing that we're going to be doing is actually moving our constant term. So we want to get our variable term isolated. So the 5 is going to be moved. And then we need to isolate the variable. We need to multiply by, or I'm sorry, divide both sides by the coefficient. So x is going to equal, do it in your calculator right now, 21.25 divided by 1.25. X is going to equal 17. So my final step is going to be writing a sentence to answer the question. Marvin played 17 games. Now I should take that 17 and plug it back in for x. So I should, in my calculator, if nothing else, I'm going to type in 5 plus 1.25 times 17 and then hit enter. You should get 26.25, and that does equal 26.25. There's no reason to get a wrong answer because you can always check your work. Okay, turn the page to page 69, and we are going to do a consecutive integers problem. Hopefully you remember from lesson 1, I want to say, consecutive integers means right in a row. So like 1, 2, 3, 4 are consecutive integers. Now I'm trying to figure out which consecutive integers, when they're added together, when they're summed, are going to equal negative 26. So I don't know any of the integers at this point. I just know they're going to equal negative 26. So I'm going to say x is the first integer. if I'm at 1, say my first integer is 1, and I'm trying to get to the next consecutive integer. I'm trying to get to 2. What do I add to the 1 to get to 2? So x plus 1 is going to be my second integer. Again, if I'm at x, if I'm at 1 and I'm trying to get to 3, what do I have to add to the 1? So it'd be x plus 2 equals the third integer. And then, of course, x plus 3 is going to equal my fourth integer. Now I'm going to have to add them all together because I need the sum of all 4 integers to total negative 26. So I'll have x plus 1 plus x plus 2 plus x plus 3 equals negative 26. Collect like terms. We have 4x plus, let's see, 1 plus 2 is 3, plus 3 is 6. Now again, I've got my like terms combined. I only have my variable term on one side, so I'm going to start by getting my constant terms all on the other side. So minus 6, 4x is left on the left side, and the right side, negative 26 minus 6 is going to be negative 32. Divide by the coefficient, and x is going to equal negative 8. So my first integer is going to be negative 8. Negative 8 plus 1 is negative 7. Negative 8 plus 2 is negative 6. Negative 8 plus 3 is negative 5. So now I need to check, does negative 8 plus negative 7 plus negative 6 plus negative 5 equal negative 26? Do it in your calculator. And it does. Some of these problems are problems that we've actually already translated. We already worked these problems in lesson 1 and lesson 2, and in fact I think this one with the book pages we've already translated once. So they're telling us the book has X pages, so they've already defined the variable for us. X equals the number of pages in the book. And Maria is reading, and she reads 45 pages on one day. And then the next day she reads half the book. If the book has a total of X pages, half the book is going to be 1/2 X, or it could be X divided by 2. And the remaining 72 pages on the next day. And we want to know how many pages there are total. So again, we're going to collect some like terms. We've got 45 plus 72. Use your calculator. What is 45 plus 72? It is 117. We still have 1/2 X, and that equals X. Now I could, at this point, multiply through by 2 to get rid of the fraction. However, I think half is really easy to deal with. So if I'm subtracting 1/2 X from the left side, I've got to do that to the right side, 1/2 X. So what I'm going to be left with is 117 equals 1/2 of X. Now, this is 1/2 times X, or the other way to show it, I said before, was X divided by 2. So the way that you're going to undo that, the way that you divide by a fraction is by multiplying by the reciprocal. So whether you showed it as X divided by 2 or 1/2 X, you're going to be multiplying both sides of this equation by 2, and you'll be left with X equals 234. So now you can type a response, or write, I guess. 234 pages in the book. And again, I can take that 234, plug it into the original equation, and make sure that the left side will equal the right side. And go ahead and take the time to do that in your calculator, and you'll see that it does, in fact, work. Okay. Number 6 says a number increased by 5. So we don't know what the number is. So x is going to be the number. So x increased by 5 and divided by 2 is equal to 75. So how am I going to show this? X plus 5, whatever that is, divided by 2 is equal to 75. This is one of those times where I would, even though it's 2 and 2 is relatively easy to deal with, I would go ahead and multiply the entire thing by 2. Then you'll have x plus 5 equals 150. Subtract 5, and x equals 145. So again, let's just make sure that works. 145 plus 5. So if I plug it back in, 145 plus 5 divided by 2 equals 75. Let's see if it works. 145 plus 5 is 150 divided by 2. And that would be 75 equals 75. Don't even need a calculator for that one. Okay, number 7. The sum of 13 and twice a number. We don't know the number, so x is a number. Twice a number is 2 times the number, remember, is 7 less than, turnaround phrase, 6 times the number. So 6x minus 7. What is the number? So let's set this up. 13 plus 2x is equal to 6x minus 7. We have variable terms on both sides, so we need to get them all to one side or the other. I'm going to move the 2x, so negative 2x. Whatever I do to one side, I've got to do the other. So I'll have 13 equals, that's 0. 6x minus 2x is going to be 4x minus 7. Move all my constants to the other side. Divide by 4, and x equals 5. So the number is 5. Again, we can check it. The sum of 13 and twice a number. So 13 plus 2x is going to be 23. 6 times 5 is 30, minus 7 is also 23. So that works. The nice thing about this particular section, at least so far, is we've had all whole number answers, which is kind of nice compared to what we had on last night's lesson. Let's go ahead and set up number 8 together. The width of a rectangle. So what I tend to do when I have things that I need to kind of visualize is I would draw something. So I've got a length and I've got a width of a rectangle. This one is kind of tricky. So the width of a rectangle is 7 less than twice the length. If the perimeter of the rectangle is 43.6 inches, what is the area of the rectangle? So if they're giving us a perimeter, we have to figure out what the length and the width are, and then we'll have to take that length and width and multiply them by each other to find out what the area would be. So this is a really complex problem. So let's take a look at what we know, or what we don't know, I should say. Let's have x be the length. So the width, if that is the length, the width is 7 less than twice the length. So 2x minus 7 is going to be the width. When we're doing the perimeter, we'll need one length, and we'll need this length, and we'll need this width, and we'll need this width. So we'll need two lengths and two widths. So I'm going to have 2x plus 2 times the quantity, 2x minus 7, and they're giving us that it equals 43.6. So the width of a rectangle this is what we don't know. Okay. So now we get to solve this equation. Again, going through the steps that we always go through. We've got something to distribute here. So we'll have 2x plus 4x minus 14 equals 43.6. Now I can combine some like terms. 2x plus 4x is going to be 6x minus 14 equals 43.6. The opposite of minus 14 is going to be plus 14. So I'm going to add 14 to both sides. 6x equals 57.6. Divide by 6, divide by 6. I just said we had really nice numbers, and now all of a sudden we don't anymore. So x is going to equal 9.6. So if that is our length, I need to figure out what the width is. So the length is 9.6. The length, oh, I'm sorry, that's the length, the width. So now I need to take 2 times the quantity 9.6 minus 7. And if I put that in my calculator, I get 12.2. Now the area of a rectangle is your length times your width. So I'd have 9.6 times 12.2. And if I put that in my calculator, I get 117.12, and these are inches squared. This is a very complex problem. Hopefully you were able to follow me on it once we got it all worked out. Number 9. 250 tickets are available for sale at a school dance. On Monday, 35 tickets are sold. An equal number of tickets were sold each day for the next 5 days. How many tickets were sold on one of those days? So X is the number of tickets sold Tuesday through Friday, right? For the next 5 days. Okay, so we're going to equal 250 because that's the total number of tickets that are available. On the first day we sold 35. Then if we sold an equal amount over the next 5 days, that's going to be 5x. This is relatively easy because all of our variable terms are on one side. So I set this up for you. How about if you go ahead and finish solving it and figure out how many tickets were sold on one of those days for 5 consecutive days. And then the next one, Shauna skateboarded for some number of minutes on Monday. on Tuesday. So X is the number of minutes on Monday. On Tuesday, she skated for twice as many minutes as she did on Monday. So 2X is Tuesday. On Wednesday, she skateboarded for half the sum of the minutes from Monday and Tuesday. So we need to add together Monday and Tuesday, and then multiply it by 1/2 or divide it by 2. And that's going to be Wednesday. Altogether, she skateboarded for a total of 3 hours. How many minutes did she skateboard each day? So I want you to notice here that they're mixing hours and minutes. So the first thing I'm going to do is take 3 hours and say how many minutes is 3 hours. So we know that there's 60 minutes in 1 hour. So 60 times 3 is going to be 180. So that's 180 minutes. We need to keep our units the same. So if I'm setting this up, I'm going to have Monday plus Tuesday plus Wednesday equals 90. And I'm looking at that fraction in there and I'm going, I don't like it. I'm going to multiply the entire thing by 2, get rid of that fraction. So I'll have 2x plus 4x plus x plus 2x equals 180. Whoops, what did I do? I made a mistake here. You're probably all yelling at me. Sorry about that. I don't know why I plugged that in incorrectly. So that's 180. So if I multiply that by 2, that's going to be 360. So now I need to collect some like terms. I've got 2x plus 4x plus x plus 2x. That's going to be 9x. Divide by 9, divide by 9. So x equals 40. So she skateboarded for 40 minutes on Monday, 2 times 40 minutes on Tuesday. So that's going to be 80 minutes on Tuesday. And then 40 minutes plus 80 minutes divided by 2. So 40 plus 80 is 120 divided by 2. That would be 60 minutes on Wednesday. So let's add this up. 40 plus 80 plus 60 is 180 minutes. So that works. We are going to call it a day here. We're not going to do the last problem at this time, and we will pick this back up tomorrow. Sorry it went so long. Hopefully it helped and it set your mind at ease a little bit when we are looking at story problems. Do a couple in class tomorrow together. Have a good night.